I'm Jason Lewis.
And I'm Thomas Mills.
Welcome to Climate Optimists. As a group of concerned citizens, we're on a journey to explore climate solutions and ways that each of us can make a difference. Flora is out this weekend doing a little backpacking around Europe. We're both jealous, so we're living vicariously. A quick thank you to all our monthly supporters. As a nonprofit, it's your donations that enable us to educate and empower people to make a difference on climate. And, if you're interested in joining our community supporters, it's really easy. Just head over to our website, climateoptimist.co, and click the donate button. And, even $5 a month really makes a difference for us.
As a reminder, this will be our last episode before we break for the Northern Hemisphere summer. Our fall season will kick off in September. Yes, I had to clarify, Lewis. If you are a regular listener, make sure you've signed up to our monthly newsletter. This will ensure that you get hopeful climate news and ways to get involved delivered straight to your inbox. It will also allow us to keep you posted on our podcast fall season.
Yeah, it takes just a minute to go do it. If you do one thing, put us on pause right now and go over and sign up there. We don't want to miss you when the fall season kicks off. Today, an average car in the U.S. with an internal combustion engine gets roughly 33 miles a gallon, give or take, which, by all measures is pretty pathetic. With hybrid technology, cars like the Toyota Prius can get you about, 57 miles per gallon, more respectable. But when you jump to an EV, something like a Tesla Model 3, you can get the equivalent. Obviously, you're using electrons instead, but the equivalent of about 132 miles per gallon. And while that's impressive, a recent analysis completed by the Electrical Power Research Institute, or EPRI, projects that EVs could get an equivalent of 250 miles per gallon by 2050. And, this will not only provide significant benefits to EV owners, but it massively reduces how much additional generation capacity our grid needs to be able to support our transition to EVs. But before we dive into the future advancements in EVs and what they mean, let's talk about this week's reason for hope.
Thanks, Jason. According to the International Energy Agency's 2024 outlook, the global EV market continues to expand rapidly. The highlights are that globally, more than 1 in 5 cars sold this year is expected to be EVs. And by 2030, the EV forecasts are that 1/3 of the cars on the road in China and 1/5 of the cars on the road in the US and the EU will be electric vehicles. And this will contract the oil demand by approximately 6 million barrels a day. The good thing is that the International Energy Agency has been overly conservative with pretty much every estimate I've ever seen for the transition to a sustainable economy. So I am hoping at least that these numbers are woefully underquoted and that we will be at much higher percentage penetration rates by that point in time. The other good thing is that 2- and 3-wheel EVs are quickly catching on in places like India and Southeast Asia, of which, there are a lot of these vehicles compared to, normal 4-wheel internal combustion vehicles. And often they're 2-stroke, which is even worse. And this is delivering great improvements in air quality in those regions. And nearly 60% of 3-wheelers sold globally last year were sold in India.
Yeah, it's cool how there's, these ancillary benefits, right? I mean, I think everybody knows that places like Delhi and Mumbai have pretty terrible air quality. And so not only are these countries, getting the benefits of EVs in terms of, cheaper to operate, lower carbon emissions, but it's improving their air quality too. Well, with that, let's get to today's guest. Dr. Geoff Blanford is a principal technical executive in EPRI's Energy Systems and Climate Analysis Group. He leads the development of energy systems modeling at EPRI, and his current research activities include energy system integration, end-use electrification, and economy-wide decarbonization policy. He is also a lead author for the Intergovernmental Panel on Climate Change Fifth Assessment Report and serves as a co-director of the International Energy Workshop. Geoff holds a PhD in Management Science and Engineering from Stanford University. And yeah, we're stoked that he's here to talk about EPRI's recent analysis. Geoff, welcome to Climate Optimists.
Hey, thanks a lot. It's great to be with you.
So let's start you off with the question we do all our guests. When it comes to efforts to address climate change, what makes you hopeful?
I really like this question. I like the way you framed the conversation around optimism. And I think for me, the answer always starts with technology. When you look at the technology innovation that's going on that we project in the future when we think about future scenarios, really is a lot of potential for improvements across the energy system that will move things in the right direction. And electric vehicles are really the top of that list. You'd be hard pressed to think of something that is going to have a bigger impact and is sort of more poised in terms of the economics are aligned, the environmental benefits are aligned, and really trying to understand what the potential is and how it affects the system and the benefits from customer cost to emissions to air quality, climate, there's a whole range of things that are really exciting about electric vehicles. So that's really what motivated us to look at this report. We collaborated with, NRDC, the National Resource Defense Council. We've collaborated with them in the past on similar questions. I think I came away from this report more optimistic than ever about the potential for electric transportation and the kinds of technology innovation that we looked at here to really make a big impact.
Well, that's a great intro. Let's just tee it up then. So I guess starting out kind of big picture for folks who may not be, totally acquainted with kind of the technical aspects. Let's just start about, the efficiency of electric vehicles and why, kind of at a macro level, EVs are more energy efficient than a typical internal combustion engine.
Yeah, I mean, it's pretty straightforward. EVs are sort of a step change in improvement over an ICV because they don't have the thermal losses of an internal combustion engine.
All the heat.
So, all the heat, right. So there's a lot of waste heat, which is nice if, it's 0 degrees outside, you get sort of free cabin heating in an ICV. But generally, that's, lost energy that EVs just don't have. So the energy from the tank to the wheels, or the energy consumed within the vehicle, is maybe 3 or 3.5 times lower, kind of for an equivalent vehicle if you compare an ICV to an EV. That's for a light duty driving cycle. Heavier vehicles might be a little bit, the premium might be a little bit lower, but the difference in energy use by the vehicle is just dramatic. And that's really sort of at the core of the opportunity for EVs to revolutionize on-road transport.
So a lot more of the energy getting delivered to the wheels as opposed to, going up in waste heat at its core.
That's right. From the battery to the motor, moving the vehicle forward.
Well, let's kind of get into sort of the next question, which is, how do today's EVs kind of compare to internal combustion engines from an efficiency perspective? And I know there's, different kind of equivalencies out there, kind of miles per gallon equivalent, et cetera.
Yeah. So if you look at a typical ICV, maybe one that's newer, of course, there's a big range depending on size and, whether it's a hybrid drivetrain or not, that actually makes a difference. But if you just take an ICV, say like 33 miles per gallon, that's maybe a benchmark, and then you compare it to a sort of equivalent EV, similar size and style, that's going to have maybe over 100 miles per gallon equivalent.
Wow.
Now, those are kind of weird units because it's not gallons, right, of electricity, it's kilowatt hours, but it's an energy unit, and so when you do all the conversion, that's about a factor of 3 improved.
Right. So,
and it's for the same vehicle, right? If you look at bigger vehicles, then that there's more energy used, but the ratio is
okay. So, and this kind of leads, I guess, into the report, which was super exciting to read. What sort of improvements are anticipated to be made with EVs, kind of on the horizon, and where are those kind of coming from?
Yeah. So, if you look at all vehicles, even IC vehicles, have experienced efficiency improvements over time, and so some of those same strategies would apply. Like lightweighting is a big thing, right? The lower the mass of the vehicle, the less energy it takes to move it. So that's a strategy that can continue to apply to current, the current suite of EVs. High strength steel is a material that can provide the same structural benefits at lower weight. Another big part of EVs, a big part of the weight is the battery. So improved energy density of the battery has sort of a compounding effect. It lowers the weight of the vehicle, which makes the vehicle require less energy, which means you need a smaller battery. Other things are like aerodynamic styling, things as simple as replacing the rearview mirrors with cameras can make a big difference. A lot of these vehicles have cameras in them already. I think it's currently illegal to have a vehicle without rearview mirrors, but folks are trying to get that changed. Cameras can do the same job safety-wise, then you definitely get an improvement in the aerodynamics. There are things like tire rolling resistance. There are things within the drivetrain of the electric, the motor efficiency, charging efficiency. And then a big one for EVs is cabin conditioning, right? Like as we mentioned, you get sort of heating for free in an ICV, but you have to consume electricity to heat the cabin and also to condition the battery at low temperatures. And that ends up being a pretty big component of the vehicle's energy use. So strategies to reduce that using heat pumps and other smart strategies. So all of those things combined, you can get a vehicle that is getting 100 miles per gallon equivalent today to something more like 250 miles per gallon equivalent by 2050.
Wow.
And that's with like all these strategies applied. And that's sort of our most advanced scenario. We looked at a range of scenarios. And we don't know just how much these strategies will be adopted. But the idea here was to look at, well, what's technically feasible and what's the technical potential for improving efficiency in these EVs. And again, it's like the EV is already more efficient than ICV, which is great. And that drives why we're interested in it. But doesn't mean we stop there, right? And I think that was kind of the insight here, that there's still a lot that could be improved, and it actually does have a huge impact on the system, which is one of the things that we look at a lot as electric system researchers. What does this mean for electricity load? Because you have efficiency on the one hand, but you also have new load. Both of those things are true at the same time.
So it sounds like at a macro level, more energy dense batteries. So we're carrying less weight. That allows us to, convey ourselves further, more efficiently. Our cars are getting, more sleek, more aerodynamic. We're not moving to a heat pump instead of effectively an electric toaster to heat the cars.
Right.
So all those things in aggregate, more efficient. And I think you sort of alluded to this, but this then has huge implications for our demand for electricity and in turn kind of transition to renewables. So I wonder if you could talk about that a little bit, like sort of the knock-on effects that this is anticipated to have.
Yeah. The scale of let's just think about light duty, right? This is the part that's sort of connected to household decisions. And the scale of light duty vehicles today, energy use, liquid fuels used for light duty vehicles, this is maybe 20% of our total emissions. So when we shift that to electricity, all those direct emissions from the liquid fuels are going away, as well as local air pollution that's associated with it, not just the greenhouse impacts. But of course, the other side of that coin is, well, now you've increased your electricity demand. And so this could be the sort of single biggest source of electricity load in most households. And so one big thing becomes another big thing, but has much lower emissions footprint, it has lower costs, and overall a more efficient way of providing the same service. But it does have implications on the electric system. So if you look at the increase in electric load by 2050, with no change in efficiency, you're talking about maybe a 60% increase over today versus maybe about 30% in the most efficient scenario. So that's a huge difference, right? This is probably the biggest single load coming onto the system in future decades. So if you have this opportunity to leverage the efficiency, that creates benefits sort of across the system, but really by reducing the scale of the required build out.
In other words, potentially fewer transmission lines, fewer solar panels, fewer wind turbines, and then maybe I'm wondering sort of in conjunction with that, it's like if we aren't adding as much load to the system, then that enables us to, in theory, decarbonize faster.
You're right that the scale of the challenge is related to how much electricity you're trying to provide. And so when you have lower demand coming from this new big load, you have less generation infrastructure, less T&D infrastructure, less charging infrastructure potentially. I think the required build out is really something that utility planners are worried a lot about. Right. And if you have to, adding things quickly is a challenge. And if you can, fit more service into less investment, that makes everything easier.
Right. So in essence, kind of putting it in basic terms for folks, it's like not only are we seeing this massive transformation take place in our electric grid, trying to move away from fossil fuels, but it's like we're also asking all these folks who are involved in that to now take on additional load as we try to transition our other elements of our economy over to, electricity. So the less or the more efficient we can be in terms of what we're adding, the better off we are. Well, I guess wondering how these EV efficiency improvements, how that translates to kind of the consumer in terms of, cost upfront, cost of ownership, et cetera.
Yeah, so that's that's an important piece of this. And one of the things we looked at was cost savings, and alongside the scale of that build out is reduced cost, right? You're spending less on all that infrastructure from the electric side, but that gets translated into fewer expenditures on electricity by the consumer as well. So, if you're an EV owner, you're already spending much less per mile on fuel, maybe as much as 3 or 4 times less, to the point where your electric and what you're spending on electricity is a really small part of the total cost of ownership of an EV. So, those savings might be on the order of, a few $100s a year for a vehicle, which gives a small percentage. But when you multiply that by all the EVs, you're talking about sort of hundreds of billions of dollars that's being avoided. So it's happening at both the system level and at the customer level.
So imagining, because you mentioned it already, changes in batteries, how these anticipated efficiencies that we're going to be realizing with EVs, how that potentially impacts kind of the type of materials and volume of materials that we need for these EV batteries.
It's a little bit tricky to project a material material balance. I think we did some back of the envelope numbers around sort of lithium if you assume same technology going forward. But what I think is maybe more salient is look at, well, how much battery capacity am I having to build versus how much am I saving if these vehicles can have smaller batteries?
Right.
And that's, you can see something like, I think we calculate like a 57% decrease in the amount of battery capacity that you would need to produce on an annual basis. And that's within the US. The other thing that is interesting about this efficiency trend is that efficiency has always been tied up with, it's been really important to EV design because it impacts how big the battery has to be to achieve a certain range. And so when the efficiency improves, you need less battery to get the same range. And so the question is, well, is that going to translate to a smaller battery, or is it going to translate into a longer range with similar size battery? With efficiency improvements, I guess the size of the battery kind of becomes more of a design choice for the vehicle manufacturer. And I think in most cases it would result in a smaller battery, but you have options there too.
And I'm sure a lot of variables that are probably a complex thing to try to predict how that's going to shake out. In other words, like you have dimensions like, if charging times continue to drop, then people, and charging infrastructure improves, then, if there's folks who perceive that they need 500 miles range, maybe that perception changes. You realize that that's not necessary to do the driving that you need to do.
That's right. Yeah, it's very, it's just such early days for this market that preferences are not settled for sure in terms of range and other sort of key factors in how the vehicle's designed. So we have to wait and see kind of how that market evolves. But regardless of how preferences evolve, and I think you're right that the charge infrastructure will kind of reassure the vast majority of drivers that 500 miles is probably overkill, and that's based on kind of our analysis of travel patterns. And charging infrastructure definitely enables a smaller battery, smaller range type of approach to vehicle design.
Well, fingers crossed on that one. I know, we talk about sort of the macro level environmental impact. Obviously, we can get by with a smaller battery. I think that, that has a lot of potential benefits. I know myself, when I first bought an EV, I assumed I was going to, 300, I questioned whether that was enough. And, here I am 3 or 4 years later, and it's like, that's plenty. Wondering, have kind of a different kind of question, thinking about these, upcoming kind of efficiencies. How are, and I don't know if you looked at this in your model, how might that impact kind of our anticipated use sort of, or dependence on cars? Like if we kind of zoom out and we say that, obviously an electric vehicle is, from an environmental perspective, is better than an internal combustion engine. An e-bike is even better than a car, right? So on and so forth. Did you guys look at that at all? And if you did, kind of, what did you see?
Yeah, so we didn't directly model what I would call sort of modal choice, or actually trading off different types of mobility between, or reducing the amount of mobility service that you're demanding. So we kind of held that VMT constant. Kind of VMT per capita was assumed to basically stay the same. We did look at a scenario where VMT decreases, VMT per capita goes down, vehicle
VMT
miles
stands
traveled,
for. Oh,
vehicle
okay.
miles traveled. Sorry, vehicle utilization. So people driving less over time for whatever reason, maybe changes in urban development, changes in preferences, changes in commuting patterns. Um, so that was a sensitivity case that we looked at to just give a sense of, well, um, how much kind of lower could you imagine electricity demand being at the same time as the vehicle efficiency improving? It has an impact. I think the reduction, an anticipated reduction in the driving per person, um, I would anticipate lower reduction in that than in what's potential from the energy consumption for the vehicle. But there are a lot of potential drivers in it, and it goes much beyond the energy question, right? Sort of lifestyle questions about how urban planning proceeds and what are communities doing to counteract sprawl and sort of create communities that that look more like the compact cities that can get by with great public transit systems that you find in other parts of the world. So that's certainly potential. But the bottom line, mobility is valuable, right? So you've probably seen the work of Andreas Schaefer, transportation researcher. I think he's at UCL, University College London. He has this great sort of historical perspective, which is that people over centuries spend about an hour per day moving around, and that's kind of been held constant across societies and across major technological changes. As technology changes, you just move further within that hour, on average. And what the takeaway that I get from that is, mobility is valuable
Right.
for a lot of reasons, and so going forward, probably we would expect mobility to continue to be a service that people demand. And electric transportation is probably the most promising way to meet that service demand more sustainably. But I don't want to discount the potential for public transit, biking, walking, other things that I think have a lot of side benefits as well, becoming a bigger part of the mix.
But to your point, maybe, more influenced by how we plan our cities than the technology itself.
Yeah, I mean, I think it gets down to a lot of, and it's a longer term. These can be longer term investments as well. How you affect the way people kind of structure their living patterns and where they move and where they commute and what options they have to do that.
Right. That makes sense. So, Geoff, as people are listening to this and getting excited, and our folks that are concerned about climate change, thoughts on kind of what they might want to consider do next? I mean, maybe research more, or, wondering what your perspective is there.
Yeah, I mean, this study was all about kind of trying to understand the technical potential for both efficiency and electrification to, have benefits across the system. And I think a lot of EPRI's research has tried to document for a range of technologies. I mean, it's not just electric vehicles, but it's true for, as I mentioned, kind of heat pumps and a lot of industrial electrification technologies. The research that EPRI's done has really tried to lay out, well, what are these benefits? What are the technologies that are available? What are the what are the potential costs and savings? What are the emissions impacts? I think those resources can be really helpful just to kind of learn more. I mean, this information barriers tends to be a big one
Right.
for folks considering new technology adoption, and so just trying to inform those decisions is something that we've spent a lot of time on.
Well, we'll include some links in the show notes so folks, if they want to learn more. I mean, I think knowledge is power, and in this transition, there's a lot of good technologies out there, and frankly, technologies that have other benefits aside from just the climate ones. So, well,
For sure.
thanks for coming and talking with us about these promising developments with electric vehicles, for the work you do there at EPRI. Certainly appreciate that. Yeah, thanks for coming on.
Great. Thanks so much, Jason. It was a pleasure.
Well, a ton of information there in the interview with Geoff. Some, exciting developments on the horizon. I think it's worth just, stopping for a minute to highlight how big of a deal it is that, EV efficiency is forecast to improve by that much as it relates to the grid. Because, I think we're all familiar with this idea that, we're trying to electrify everything, right? To move us away from fossil fuels. So moving to heat pumps instead of gas furnaces, moving to EVs instead of internal combustion engines. And while all that is great, it also means that we're moving, the load source away from burning fossil fuels to, consuming electricity. And so electricity demand is supposed to expand rapidly, between now and 2050, getting to a net zero scenario. You're talking like 2.5 times the size of our current grid. And so anywhere we can reduce the amount of load that we're set to add is a benefit, right? And enables us to decarbonize faster. So that, I think, for me, is one of the biggest takeaways here, is that, becoming more efficient is important in terms of, building out our future grid.
Yeah, look, I see actually a bit of a symbiotic relationship between the grid and electric vehicles. It's typically in the media, it's always spoken about from a negative context, but I really see, especially in places like Australia, and I think we'll see the US become more like our current situation here, where electric vehicles with bidirectional charging capabilities are going to be, in my mind, absolutely critical. And the reason is that right now in Australia, we have a lot of rooftop solar that in certain times of the year forces the price on the grid negative. That means that generators have to pull off the grid because otherwise they have to pay to put electricity onto the grid. So we end up clipping the solar, right? People end up not putting that power onto the grid. And with an electric vehicle with bidirectional charging, you have a massive battery on board compared to what a regular home battery is. A typical home battery is about 10 to 15 kilowatt hours in capacity. A typical electric vehicle battery is maybe 50 to 100 kilowatt hours in capacity. So you've got now a massive reservoir that, when set up with bidirectional charging, can be monitoring the price of the grid and pull that charge off, allowing more solar to go on in the middle of the day and then using that in homes and businesses in the mornings and evenings.
Yeah, I think that's a critical point. There's a ton of focus on the demand that EVs are going to be placing on the grid, but I think, to your point, they have a really critical role to play in helping, balance out renewables, right? Because we know that our, biggest consumption times are morning and evening, and, the sun is shining brightest in the middle of the day. So yeah, it seems like an important role for them to play there as well. I think another piece, and Geoff spoke to this a little bit, but I think it's worth maybe contextualizing a little bit more, is why, EV efficiency matters kind of from a day-to-day operation perspective. And I know, Thomas, you're probably closer to this than I am, and maybe you could kind of speak to, why having a more efficient EV, sort of your miles per gallon equivalent, is important for a prospective EV owner.
Yeah, I think one of the most important things is when you are on the road and you need to stop to charge at a DC fast charger. If you have a more efficient electric vehicle, then it typically means that you'll be able to add kilometers to that car faster because you don't need as many kilowatt hours per kilometer. So yeah, vehicle efficiency, very important, not just from a charge perspective, but also from a purchase cost, because that often means that the battery size doesn't need to be quite as big, or to achieve your same desired range of, 500 kilometers or 300 miles, whatever it might be, you're able to spend less on that car because it comes with a smaller battery pack to achieve the same range.
Yeah, it's a good point, right? I mean, it's sort of like, putting a gallon of fuel into your tank in a highly efficient, let's say, Toyota Prius. You're going to be able to drive a lot further than you are putting a gallon into that big SUV. And so it's sort of the same principle with EVs and electrons, right? That the more efficient it is, the more you can go for that, that amount of charge. And to your point, it's going to make a difference in terms of either the range you're able to go and or the purchase price on the front end.
Yeah. And the other thing is that people often say, oh, but look, going with a bigger battery pack, it's going to make the car a lot heavier. Well, that's less of an issue with an electric vehicle than it is with an internal combustion vehicle. If you have a heavy internal combustion vehicle, you have to burn a whole bunch of fuel to get to the top of the hill. And then on the way back down on the other side, you're typically wasting that energy in heat, either through braking or through either through braking at the wheels or through engine braking, where the heat is just stripped off the engine and passed through the radiators into the air. With an electric vehicle, you're recapturing the majority of that energy on the descent.
Yeah, and I can attest to that firsthand. You're climbing the mountain in your EV, and you're watching your range drop, and then as you're going back down, you recapture most of it. It's pretty wild the impact it has on range. Yeah, so in hearing you talk about all this, I think, Thomas, if like people want to sort of keep one thing in mind when they're going to purchase their EVs, really focusing on the efficiency of the vehicle. So whether that's how many kilowatt hours per kilometer or miles per gallon equivalent in the US, trying to find the maximum efficiency that you can, because that has all sorts of benefits, down the road if you're as an EV owner. And since we're, talking about EV ownership, I think it's worth plugging the fact that we're seeing a lot of exciting things for prospective EV buyers. Here in the US, there's been the federal tax credit for new EV owners. You can get up to $7,500 if you're buying a used EV, $4,000. And now, thanks to the Treasury, you can be claiming that at the time of purchase. So effectively, removing $7,500 or $4,000 off the sticker price of an electric vehicle. You have exciting news like at the beginning of the year, Tesla opened up its, roughly 15,000 superchargers to non-Tesla, EV owners, which helps, alleviate, I think, a lot of the charging angst out there. And then, Thomas, you can speak to this more than I can, but there's been a lot of, exciting improvements happening on the battery side of things in terms of, advancements in, energy density and performance, et cetera.
Yeah, I think the important thing to remember is that the batteries in electric vehicles from 10 or 15 years ago are nothing like what they are today. I was looking back at a US Department of Energy Vehicle Technology Office's study on 15,000 EVs over the last couple of decades. And if you look at the battery failure rate of vehicles in 2011, it was about 7.5% of the fleet. 10 years later, that had dropped to 0.5% of the fleet. And it looks like that we achieve about an order of magnitude reduction in battery failure rates, or an order of magnitude improvement in reliability of batteries every decade or so, which is quite impressive.
Yeah, I think as my mom reminded me the other day, she's been an EV owner now for about over a decade, and she was able to make it work back then, and so there's really no reason for folks that are yet to make the leap not to jump in now, because as you point out, things are getting significantly better. And I guess this all kind of leads to the question of what can we do as individuals? And this week we've got two options for you. The first option is, I think Thomas and I both share the view that in order to really, effectively accelerate our transition to electric vehicles, it needs to become more expensive to drive internal combustion. And so that really starts with putting a price on carbon. So for our listeners who are in the US or Australia, let's try to join our Canadian counterparts and pass, something like a carbon fee and dividend. Pricing carbon obviously has positive impact on moving to EVs. It also impacts other areas of our economy. So getting that price out there is a great way to help get us on the trajectory that we need to hit our, long-term climate targets. So reach out to your elected official today and tell them it's time to put a price on carbon.
So our second option is consider an EV. Whether that's got four wheels or two, doesn't really matter. But maybe consider making that transition from internal combustion to electric vehicle. We here at the podcast are big fans of the two-wheel variety, mainly because the minerals required to manufacture that are typically about 1% of the four-wheel variety, and their electricity consumption is normally about 1/30th that of a regular four-wheeled electric vehicle. But if you are going to get an EV, it's probably also a good time to think about adding those solar panels to your house if you live in your own home.
Yeah, great point. Well, that's a wrap for our episode. Thanks as always to everyone for tuning in. And, as Thomas pointed out at the top of the episode, this is our last one before our start of our next season in September. So make sure you head over to the website and sign up for our newsletter if you're not already subscribed. Climate Optimists is made possible by Climate Stewards Collective. You can find us on the web at climateoptimist.co and follow us on social at Climate Optimist Podcast.